Assalamualaikum and hi. Today we would like to present a recycled waste material and suitable concrete for class as a fine aggregate replacement. We are from class PEC 1104A1. Your presenter today is Nushada binti Najmi, Nurani binti Ishaq, Aira Kristina binti Shahriman, and Nur Ana Nabiha binti Azizur Rahman. For introduction, the construction industries increase the demand for raw material, especially fine aggregate, has raised a serious environmental concern due to resource depletion and waste generation. In response, they study explore the use of recycled glass as a fine aggregate replacement and suitable concrete. The objective is to assess the feasibility, performance, cost efficient, and environmental impact of incorporating glass into the grade 30 concrete. Especially, the research aims to evaluate the mechanical properties such as the compressive strength, compare cost with the conventional concrete, and examine the potential benefit to the environment, industry, and community. This innovation align costly and suitable development goal 9 by promoting a responsible material usage and supporting circular economy practice. It also addresses the challenge of managing non-biodegradable waste, offering an alternative that reduces landfill burden and preserves the natural sand resources. By reviewing the current finding and case studies, particularly in Malaysia context, this project demonstrates a practical and scalable solution to the support future of the green construction. The research thus provide a comprehensive understanding of how recycled glass can be effectively integrated into a concrete industry while fulfilling a suitably and engineering objective.
For the procedure of using glass as recycled material in sustainable concrete, number one, glass preparation. Waste glass is collected, sorted, and cleaned. After that, for the crushing and grinding, the glass is then crushed and ground into different sizes depending on its intended use. And for the fine aggregate replacement, the glass is typically ground to a particle size of less than 4.75 millimeter. And second, dry ingredients, the crushed glass, cement, and any other supplementary cementitious materials mixed together. For the wet ingredients, water and any necessary admixtures like plastic scissors are added to the dry mix. For the mixing, the components are truly mixed until a consistent and workable concrete mix is achieved. The third, the third is casting and curing. For the placement, the concrete mix is placed into molds or form. Vibration is often used to compact the concrete and remove air pockets. For the curing, the concrete is cured for a specific period, example 7 days, but we in this project we put 28 days to allow the cement to hydrate and the concrete to gain strength. For pros and cons of glass concrete is the pros. Number one, uses recycled glass that diverse waste from landfills and supports sustainability. The second one, creates an architectural landscape with colorful and decorative finishes. And number three, if designed well, it can improve the durability and chemical resistance. It may have Number four, it may have improved thermal performance that supports energy efficiency, supports sustainable building. For the cons one, number first, there is a risk of alkali silica reaction and cracking if not mitigated. The second one may require special admixtures or supplementary materials. Number three, usually it is more costly than conventional concrete. Number four, quality and supply of recycled glass may fluctuate, which may lead to poor uniformity in concrete. The last part of methodology is mix design, which our group has calculated the mix design concrete form. We use 3 specimen of 150 millimeter. The dimension increased by wastage 10% and get a slump 30 to 60 millimeter. And for the glass waste, the maximum size is 4.75 millimeter. So the result of our calculation is water cement ratio 0.45 water 250 kilogram for the cement, 475 kilogram fine aggregate, 740 kilogram, and for the cost aggregate is 980 kilogram. So from the fine aggregate, we want to replace glass waste, which is 20% from that, and the result is we got 148 glass weight kilogram. And for the pre-trial mix of glass waste is 13.32 kilogram. Here is the result.
Here are the comparison of cost the material used. We have two types of concrete, which is ordinary concrete and sustainable concrete. Cost for the ordinary concrete, it costs Rm 260 until 346 per cubic meter, and for sustainable concrete, it costs Rm 250 until 350 per cubic meter. The cost for sustainable concrete is predicted to be lower than the ordinary concrete. Yet, crushed glass may vary in price, although it is usually more accessible and might be less expensive than natural aggregates, particularly in places where glass waste production is important. The cost for sustainable concrete also was estimated to be slightly higher than regular concrete. This is because the process of incorporating glass waste into concrete requires additional processing and potential specialized additive. However, even though the initial cost of ordinary concrete might be cheaper, glass waste as aggregate replacement in concrete would extend the durability of concrete, which reduce maintenance costs. This shown that it is cost-effective material. Here are the benefits of the product innovation, which is we are comparing the sustainable concrete and ordinary concrete without any waste material replacement. First of all, from the economic aspect, for sustainable concrete, the availability of these waste materials ensure more predictable and stable pricing. Second, it has a lower transportation cost and lower waste disposal cost. For ordinary concrete, it has a high cost due to the process to get natural aggregates and transportation costs. From the community aspect, sustainable concrete would creating new business in the recycling process, thus consequently providing new jobs to the people. Secondly, sustainable materials and practice are becoming increasingly in demand as developers and customers become more aware of the advantage of green building. For the ordinary concrete, it enables the development of schools, hospitals, and community centers, contributing to the social well-being. For the industry aspect, sustainable concrete do a reduction of the cost material in the production of concrete, thus lowering the price of construction materials, which would translate to more profit to the industry. For ordinary concrete, in the construction industry, ordinary concrete is favored due to the lower initial cost compared to the sustainable concrete, despite the long-term economic and environmental advantage of the former. From the community aspect, sustainable concrete would creating new business in the recycling process, thus consequently providing new jobs to the people. Secondly, sustainable materials and practice are becoming increasingly in demand as developers and customers become more aware of the advantage of green building. For the ordinary concrete, it enables the development of schools, hospitals, and community centers, contributing to the social well-being. For the industry aspect, sustainable concrete do a reduction of the cost material in the production of concrete, thus lowering the price of construction materials, which would translate to more profit to the industry. For ordinary concrete, in the construction industry, ordinary concrete is favored due to the lower initial cost compared to the sustainable concrete, despite the long-term economic and environmental advantage of the former. How the material is being used or possibility for it to be used in Malaysia. The increasing amount of land being developed for urbanization and industry, it is a result of the rapid economic expansion, particularly in developing regions like the states of Selangor, Johor, and Pulau Pinang. Communities are also expected to expand as a result of population growth. As a result, territorial competition will begin to develop, which means it needs additional land for development while simultaneously driving up demand for construction minerals for building and infrastructure projects. As a result, many residential and urban districts near the quarries have developed and expanded due to the economies and population's rapid growth. In the future, the land areas used for mining or quarrying to produce aggregates will no longer be available and will be restricted due to protection given to the accelerating population growth, as well as to the urbanization and industrialization process. In addition, the sustained use of aggregate will soon deplete the reserve. Accordingly, if aggregate consumption is not controlled and properly planned, Malaysia will face a decline in its supply. Therefore, the concrete industry needs to shift towards the reproduction and use of alternative aggregate by searching and fully utilizing the existing potential source. This shows that the potential of the material being used is high as we need to find other alternatives.
So for the conclusion, the incorporation of recycled glass as a partial replacement for fine aggregates in concrete presents a promising solution to the environmental and resource depletion challenges faced by the construction industry. With an optimal replacement level of 20% in glass concrete not only meets structural requirements such as compressive strength, but also improves durability, fire resistance, and sustainability. The study shows that using glass waste can reduce costs, lower CO2 emissions, and support circular economy practices, making it both an environmentally and economically viable alternative. As Malaysia continues to urbanize and face limitations in natural sand supply, the adoption of recycled materials like waste glass in concrete production is both necessary and highly beneficial for the future of green construction.